Developing an application with sensors in smartphones. Thanks to these sensors, it is possible to obtain various data about the person using the device and its environment. These data can be accessed with the libraries used in the mobile software development phase. Applications were developed by processing this data accessed with mathematical methods or machine learning algorithms. With these applications, it has been possible to obtain results in many areas about people using smartphones. By analyzing the data collected from the activities and movements of the person during the day with mathematical calculations or machine learning algorithms, results have emerged in the field of health, where people can detect and track their own fainting, driving, stepping, running, stopping, and sitting. It has been possible to develop applications related to this subject. The accelerometer sensor in the smartphone hardware is used to measure the acceleration applied to the device. The data obtained from this sensor gives the acceleration value affecting the smartphone in the X, Y, Z axis in plus and minus directions. These values are in G. Based on these data, the movements made by the person using the smartphone and the shaking of the device analysis can be made regarding their states and vibrations. Based on these analyses, certain inferences can be made. In the coding phase, the variables and functions of the accelerometer sensor type and sensor event listener interface from the sensor manager library can be used in the Android system to access the data collected by this sensor. The gyroscope sensor in the smartphone hardware is used to measure the orientation angle of the device in the X, Y, Z axis in the plus and minus directions. With the data obtained from this sensor, the orientation state, rotation angle and angular velocity of the smartphone can be determined. By using the data collected from the gyroscope sensor, certain inferences can be made from the analysis of the physical activities of the person using the smartphone in daily life, as used in the accelerometer sensor. In order to access the data collected by this sensor during the coding phase, the variables and functions of the gyroscope sensor type and sensor event listener interface from the sensor manager library can be used in the Android system. In this way, gyroscope data can be obtained from smartphones that people often carry with them without the need for an auxiliary factor. Although the most common method is to calculate the magnitude of the X, Y, Z data from the accelerometer sensor and compare this value with a threshold value, many different methods have also been used. In some studies, the X, Y, Z data from the accelerometer sensor were sent into a mathematical function and the output value was used together with the zero-crossing method. In some studies, the user's walking frequency was also included in the calculations. In addition to the different methods used, studies have also taken into account the activity in which the data from the accelerometer was obtained while the person was performing the activity or the position in which the smartphone was in during the determination of stepping. Although it is not directly related to human health, both physical and psychological health of a person can be injured in a traffic accident that may occur. The majority of these traffic accidents are caused by human errors and the effects of these errors. In a study on this topic, the data obtained from the accelerometer and gyroscope sensors on the smartphone in the vehicle were used, and the driver's behaviors such as aggressive cornering, aggressive brake pedal use and aggressive accelerator pedal use were detected by comparing the sensor data using the DTW algorithm. With a certain number of signals, the driver's maneuvers were identified. When another study was examined, it was seen that classes such as aggressive driving, normal driving, aggressive braking and normal braking were determined in order to detect driving behaviors with the accelerometer sensor, and datasets of the data obtained from the accelerometer sensor related to these classes were created. For activity detection, data is first collected from mobile sensors such as accelerometers and gyroscopes during different activities. After collecting the data, certain features such as speed and orientation are extracted for each activity. After these features are extracted, tests are performed and the activity is detected according to the result of the test. For activity detection, machine learning and classification algorithms such as KNN, logistic regression, SVM, random forest, naive Bayes, Bayesian networks, multilayer neural network, AMIVA, K-means clustering are important. In addition, Levenberg, marker algorithm and conjugate gradient algorithms have also been used. In a study on this subject, during the data analysis and preprocessing process using Python, the sensor data of each participant were organized by side, right or left, sensor mode, activity and session, and then organized according to the timestamp with the biostamp RC application. In order to perform the classification process, K-nearest neighbors algorithm was used with the dataset and classification was performed with different K values, such as 3, 5, 7, 9, 11. The success of the classification process performed with different K values in the KNN algorithm. The classified scenarios were realized with the application and our testing processes were carried out in order to determine its status. For the data collection process to be used in the classification process of our application, sample scenarios belonging to 3 classes were realized through the application we wrote with Android Studio and Java, and the X, Y, Z-axis data obtained from the accelerometer sensor with a frequency of 0.2 Hz were collected and saved in a file to create our data set in the specified format. Figures show the graphs of the accelerometer data collected for the sample scenarios that constitute our dataset. In order to determine the success of the classification process performed with different K values in the KNN algorithm, the classified scenarios were realized with the application and our testing processes were carried out. For the data collection process to be used in the classification process of our application, we realized sample scenarios of 4 classes through the application we wrote with Android Studio and Java and collected data from the accelerometer and gyroscope sensor. With a frequency of 0.2 Hz, the X, Y, Z-axis data were collected and saved in a file with XLS extension in the specified format to form our dataset. In order to find the appropriate K value to be used in the KN algorithm, the classification success of different values were tested and our specific results were obtained. With the data obtained by the accelerometer sensor on the smartphone, the classification process at a frequency of 1 Hz was performed with the algorithm we coded and analyzed by us by viewing it on the application. Classification processes and classified scenarios of the users are sitting state, the user's standing state, the user's walking state and the user's fainting state, which are the 4 classes we have determined, were performed with the application and our testing processes were carried out. KNN. In order to find the appropriate K value to be used in the algorithm, the classification success of different values was tested and our specific results were obtained. With the data obtained by the accelerometer sensor on the smartphone, the classification process at a frequency of 1 Hz was performed with the algorithm we coded and analyzed by us by displaying it on the application. Classification processes and classified scenarios for the 3 classes we have determined, which are the state of having the phone in the holder/front while driving, the state of having the phone in the pocket while driving, and talking on the phone while driving, were carried out together with the application and our testing processes were carried out. When users specify their weight and height and open the application, they will be able to access the relevant information on this interface. Figure shows the KNN algorithm we used, the classes we determined and the data sets we obtained as a result of the data collection process we carried out. There is an interface that allows us to observe how much success percentage we have achieved in the classification process, which is the basis of our application. In the general scope of our fainting detection application, we believe that detecting the fainting of the person using the smartphone, sending a notification with this detection and tracking the other activities of the user is useful for people who need or may need help in these matters. In the general scope of our healthy driving application, we believe that it would be useful to detect and warn the user if the person using the smartphone is interested in the phone or talking on the phone while driving. The KNN algorithm was used for both applications in the classification sections of our application. With the use of this algorithm, we tested the success of classification scenarios with K values in a certain range 3, 5, 11, etc. When we examined the success percentages after our tests, we observed that some of the different K values and different classes had a high success percentage, some had an average success percentage, and some had a low success percentage. Thanks for listening.